Okay, this last video of the Unit 9 is on circle transformations and radians and degrees. So understanding radians and how to convert radians to degrees. So we know degrees, like a full circle would be 360 degrees. And radians is a way to measure the circle as well, but instead of using degrees, so like instead of saying like this is a 100-degree angle, it tells you how many of the radiuses would fill the outside of the circle. So it's a little bit of a difficult concept to say. Let's say the radius of a circle is 3 units. So a radian would be like a radian of 6. A radian would be how many 3s you went around. So if it's like 2.4 radians, then it would be that you went 3, 3, and then 0.4 of a 3. And so it's a way to measure the length related to the radius. What you need to know for this class, that part's not that super important. What you need to know for the course is that the conversion from radians to degrees or vice versa is that there are 3.14, so pi radians every 180 degrees. So pi over 180 is the conversion. If you're going from degrees to radians, you are going to want the degrees to cancel, so you're basically having 150 degrees times pi divided by 180 degrees. I'll just write the degree like that. So the radians would be 150 times pi divided by 180. And we typically write the radians in terms of pi, so like 150 divided by 180. We would skip the pi part, we're going to put it at the end. So you get this decimal. Remember to convert the decimal to a fraction, we're going to use this F to D button here. So you're going to hit second arrow. That gets it into fraction form for us. So it's 5/6 is the fraction. So this is really 5/6 pi. So it's not a full pi, which would be half of the circle. It's close though. It's 83% of half of the circle. So it's about here if we were to go from this circle on. But all you're needing to know for this, for the test, for the radians, for this course, is if you're given degrees, you're going to multiply, well, you're really going to divide by 180 and then put pi at the end of that. So 220 divided by 180 is going to give us 1.2 and some change, so we want to change that to a fraction. So we'd hit second arrow to get it from decimal to fraction, and then it gives us a mixed number. Then we want to hit second again, and then this mixed number to improper fraction is what we want. So we want to hit second to get it to improper fraction, and it's 11/9. So this is 11/9 pi. Okay, and all of these are just dividing by 180, and then putting pi out of the simplified fraction. So whatever you get when you do 40 divided by 180, and then changing that to a fraction is 2/9 pi. So again, the way I'm changing it is I'm just going second arrow, that changes it from fraction to decimal and back. So second arrow changes it back to decimal, second arrow changes it back to fraction. Then if you're converting from radians to degrees, and they give you the radians in terms of pi, radians to degrees, you just flip the conversion. So 180 is still equivalent to pi, but we want to put the 180 over the pi this time. The pi's will cancel, so we're really just doing 5 times 180 divided by 4. So the answer would be 225 degrees. Okay. So you're just multiplying each of these by 180 over pi. Okay, so go ahead and fill out the rest of these. If you want to pause the video and fill out these other 3 that we haven't done. Okay, then 3 through the end is just kind of a quick review of arc length. So remember arc length, and you do have to memorize this formula is equal to, it's really the percentage of the circle, so that's, to get the percentage, you take the degree over 360 and times it by the length of the circle, which is the circumference, 2 pi r. So in all these problems, they'll give you, there's 3 things that potentially could be unknown. They'll give you 2 of the 3, and you're finding the last one. So on this first one, they give you the 100 is the degree, and they give you the radius is 15. So this one's straight up just plugging it in to find the arc length. So 100 divided by 360 is about 28%. Timesing it by pi and 2 and 15 gives us 26.2 inches. Same formula we're going to be using for all of these, but we're plugging in different things. So on the second one, the arc is 190 and has an arc length, so they give us 40 pi as the answer. Find the radius. So this time we're working backwards to find r. Right now, all of these things, the 190, the 2, and the pi, are multiplied by r, so we would divide those out. The 360 is divided by r, so we would multiply that. So we multiply that to the side. That cancels it. Okay, another way for me to write that would be timesing by 360, timesing by 360. That leaves me with 190 times 2 times pi times r. And then dividing by 190, 2, and pi. Cancels, cancels, cancels. And then the pi's cancel, so I can do 360 times 4 d divided by 190 and divided by 2. So remember, anytime you see a divided, anything in the denominator, you divide by those things. So 37.9 centimeters. So go ahead and try the other 2. I'm going to flash those answers if I can find them. Number 5, you can get it in degrees, is fine. You don't have to do any radians that difficult, so just do degrees. Alright. Okay, and then on the back, what we're doing is the transformations. So all circles are similar, and that's because they all have the same degrees, and they only have one dimension really, which is the radius. So all the circles are similar because the sides are proportional, so the radius is proportional to another circle's radius. And the circumference is a measurement of that. Well, and the angles are all 360, so all the way around is 360. So that means that any circle, if you wanted to map it or transform it onto another circle, could always do it by using 2 of our types of transformations. So to get C to L, we would move this circle right and down, and then we would enlarge it. So what we're writing here is we're writing the rules for those 2 things. So that's 2 types of transformations: a translation and a dilation. So left and right, and then up and down. Okay. And I'm just going to try to see if we can see through this. Yeah, you can. Alright, so if I just do this, this is circle C. Just kind of giving you an idea what's happening. And I can tell that you can see L here. So I need to move this over and down, and then it would line up on this. But it'd still be smaller, so then I need to enlarge it. So that's what we're going to be doing. We're translating it and then dilating it. So to get from C to L, we need to figure out what these coordinates are. So C is at -6, 5. And the radius is, just, you just count it, is 3. Okay, that's 3 units over. Or you can count to the left or up, any way from the center to the side or the vertical height. Okay, and then L is 4, -4. And the radius for that would be 6. Okay, so the translation, in order for -6, that's the x-coordinate for the center, to land on 4, I'd have to go to the right 10 units. So the difference between these is 10 units. So I'm translating it 10 units to the right. And then in order for 5 to land on -4, after I moved over 10 units, I'd have to move down 9 units. And you can count that if you're just not sure how to do that part mentally. How many units are between this and which direction, and how many units are between this. You just count it and say like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over, and then 1, 2, 3, all the way down to 9. For the dilation, you're comparing radius. So if it's an enlargement, you put the larger number over the smaller. If it's a reduction, you put the smaller number over the larger and you simplify. So from C to L, it's going from this size and it's getting bigger, so it's an enlargement. So we would be doing this one, which is 2 when we simplify it. So our dilation would be 2. So our translation is 10 - 9, and our dilation is 2. And that's to get from C to L. So to move circle C onto circle L, that's what you have to do. So then, to move back from L to C, you would have to reverse directions. So starting at L, if I want to get to C, I would move left, because you always do the X first. This is the X, this is the Y. So I'd move left, so -10, and I'd move up, so +9. So we reverse the signs. And then this one's a reduction, so L would be getting smaller if it landed on C, so I would be using the 1/2 for that. Okay, so you can pause it and try W to J and J to W. I'm going to go ahead and just write the coordinates on mine and then go through the process. Okay, so hopefully you tried it. So I'll go through this. So this is, we're going from W to J. So starting at W, to get to J, you have to go left. And there's 6 units you have to go, so it's translation of -6, that's the left. And then you have to go down from 4 to -3, so that's down 7. Okay, and then the dilation, because it's getting bigger, I would put the larger number on the top, so 8 over 6, and then I would simplify that. So 4 over 3. J to W would switch it, so it would be 6 and 7, and D over 3 over 4. So it's a reduction from J to W, so I would put the smaller number on the numerator. Okay, and that's it for 7. For 8, the circles have their standard form equations to describe the transformation to get from G to H. So we still need to figure out the center like we did and the radius for each circle. And then we can compare, just like we did here, the translation and dilation. So the center for this would be 14, -12, and the radius would be 7. And that's pulled again from the opposite sides of this and the square root of this. Okay, so then you have your, from G to get to H, you have to go 4 units to the right, because 18 is to the right of this, so you're going to go 4 units to the right. And from -12 to get up to 8, you have to go up 20 units. So the translation would be 4 units right and up 20 units. Okay, if you weren't sure to do that mentally, you could do 18 minus 14. So it's x2 minus x1 and y2 minus y1. 8 minus -12. Okay, and the dilation would be 7 to 14 is getting bigger, so we put the bigger number on top. So it's a dilation of 2. Okay, so that's 7 and 8, 9 and 10. You can try it on your own, and I'll flash these answers up for 9 and 10. Okay, and then the last 4 is similar to what we just did, but this time we're going to get the center and radius and then move the transformation amounts to find the new center and radius. So the standard is, or the target is for us to be able to transform points to determine the new circle's center and radius. But we're going to write the equation for circle L prime after it's been transformed. So circle L originally is this equation. So the center would be opposite signs of these, so 4, -4. And the radius would be the square root of this, so 6. Then if we move left 4 and up 4, so or if we're at 4 and we move left 4, basically we're going to be plugging in a 4 here and a -4 here. So the new center is going to be 4 minus 4, so 0, and -4 plus 4, so also 0. So the new center is going to be at 0, 0. We're going to move back to the origin. The scale factor, you just multiply it by the radius that you had. So you multiply 6 by 3/2. 6 times 3 is 18, divided by 2 will give you 9, so the new radius is 9. So if we wanted to write the equation for the L prime, it's going to be x and y squared, because we don't have a parentheses since they're zeros, and then 9 squared, which is 81. And then same thing for the bottom half. So I'll do 13. What's the new center of the radius, center and radius of the circle with the equation that undergoes this type of transformation? So original circle, we have the center and the radius. Go ahead and pause it and find those. Okay, so it was -4, -2, and 9. And then it undergoes a 8-unit right translation. So we move from -4 8 units right. So we're plugging in a -4 here. So it's going to land at 4. And then -2, it moves 6 units down. So -8. And then the scale factor was 3. So it's 3 times bigger than it was. So the radius is now 27. And this one just wants to know what the center and the radius are, so we're done. So that's what you're doing for 12 and 14. And then the bottom questions are things for you to reflect on, but in order for you to feel like you really mastered this stuff, these should be easy questions to answer. If not, then you need to go back and look at whichever topics you don't understand and let me know. Okay, so the answers for the last 4, they're here, so you can just... yeah, 10 through 14. Yeah, so you can check them. So 10, they're here, like in the columns this way. Okay, and that's it. That's the 3 packets for this unit. Hopefully, you understood all that. If not, then I will be here Thursday after school, and in the morning on Monday, you can come with any last minute questions.